All right, last one. This is question number 6 from the 2025 AP Calculus BC exam, and I'm going to work this one out for you. I have not read the question yet. I have only looked at the questions closely enough to know what was shared among the AB and BC exams or between the two. This is almost certainly going to be the series question. If I make mistakes, please comment and let me know, because like I said, I have not read the question yet, so you get to see me solve this in real time and process the problem on my own or without rehearsing it. All right, number 6. Taylor series is given by that. Use the ratio test to find the interval of convergence. This takes a long time. All right, interval of convergence, and justify your answer. So this is going to take a bit of time here. Number A, interval of convergence, we need to do the limit as n goes to infinity of the n plus first term, that's x minus 4, and n plus 1 will be n plus 2 over n plus 1 is n plus 2 times 3 to the n plus 1 times the reciprocal of the original n plus 1 times 3 to the n all over x minus 4 to the n plus 1. And on the AP exam, you can't do this, like use different colored pens, but I'm going to because it makes it easy to see what's happening here. Let's start canceling. So I have one more x minus 4 on top than I do on bottom. I have one more 3 on bottom than I do on top. And I will apply the absolute values to everything that it can affect. So that's going to be the limit as n goes to infinity of the absolute value of x minus 4. N plus 1 will always be positive, so I can take it out of the absolute values. Same thing with n plus 2, and the same thing with 3. And the answer to that limit, top and bottom degrees are equal, so the answer to the limit is absolute x minus 4 over 3. I need, for the radius of convergence, or for the interval of convergence, I need the ratio test to give me a result that is less than 1. That's going to happen when absolute x minus 4 is less than 3. So there's my radius of convergence. Now, as far as the interval, that's going to be when negative 3 is less than x minus 4 is less than positive 3, which is when 1 is less than x is less than 7. And the one thing I like to do on these problems is confirm that the middle of that, the number right in the middle of 1 and 7 is 4, and that is the center of the series. So just confirms that my internal interval of convergence is correct. Now the pesky part, we have to test each of the endpoints. So now I've got to come over here, and I have to test x equals 1. And when I plug in 1, I have the series. You can just leave it on your desk. That'll be fine. Thank you. N equals 1 to infinity of, what am I plugging in? X equals 1, so that will be negative 3 to the n plus 1 all over n plus 1 times 3 to the n. No, it's not going to be that clean. Let's see. Wait, is that right? Yeah. Okay, so I do a little bit of cleaning up here. This one's going to be the tougher one to evaluate. N equals 1 to infinity. So that's negative 1 to the n plus 1 times 3 to the n plus 1 over n plus 1 times 3 to the n. This will cancel all but that. I can take that 3 out. So that's 3 times the series. N goes from 1 to infinity of negative 1 to the n plus 1 over n plus 1. I know that's going to converge, but I'm going to show that through the alternating series test. And so the limit as n goes to infinity of 1 over n plus 1 is equal to 0. And the terms do indeed decrease, because 1 over n plus 1 is less than 1 over n plus 1. Therefore, converge for x equals 1 by the alternating series test. This is so much writing. And just to keep things separated, I'm going to do the other endpoint in green. So now I need to test x equals 7. This will probably diverge. That's going to give me the series. N goes from 1 to infinity of 7 minus 4, which is 3 to the n plus 1 over n plus 1, 3 to the n. That will cancel, and I can pull this 3 out. That's going to be the same thing as 3 times the series of n equals 1 to infinity of 1 over n plus 1. And that diverges. That's your harmonic series. You're just missing like the first term. So this is your, that's going to diverge. It's harmonic. Therefore, my interval of convergence is, we will include x equals 1, not include 7. So you can do interval notation, 1 to 7, or you can use set notation, 1 less than equal x less than 7. And there is your interval of convergence. A lot of work. I'm going to have to go on to another page for the rest of this question. So I'm going to copy that, new page, and let's look at number B. Find the first 3 non-zero terms and the general term for f prime. This is actually not going to be bad. This is going to be a good one. B, f prime would be, and the derivative of my first term would be 2 times x minus 4 over 2 times 3. My next one is 3 times x minus 4 squared over 3 times 3 squared. What am I doing? The first 3 non-zeros. The derivative of my third term is 4 times x minus 4 cubed all over 4 times 3 cubed. Yeah. And then the derivative of the general term is going to be n plus 1. Bring down the n plus 1. Leave x minus 4 alone. Subtract 1 from n plus 1. And that's going to be over n plus 1 times 3 to the n plus, and it would go on forever and ever and ever. And just a point of emphasis on this one, I can write f prime of x is equal to, because we included the general term. If they only asked for the first 3 non-zero terms and that was it, then we would need to say f prime of x is approximately, because once you terminate your series, you then enter the world of approximations. Okay, so let's look at question number C. I just had a student come in and stop my thought process, but I think I had covered all of that for number B. So C, the Taylor series for f prime, is a geometric series for all x on the interval of convergence. Show that f prime is equal to x. Oh, that's kind of nice. They tell you it's a geometric series. Okay, so my general term, so f prime is going to be the series, and I just think better seeing it like this. N equals 1 to infinity of, oh, this is nice because those n plus 1s cancel. Oh, sexy. All right, x minus 4 over 3 to the n power. And when n is 1, my first term is, and I can actually look up there for my first term. My first term is going to be x minus 4 over 3. And my ratio is also x minus 4 over 3. Therefore, the sum of the series is going to be my first term, x minus 4 over 3, over 1 minus x minus 4 over 3. And that generally will be acceptable, but we need to show that that is the same thing as x minus 4 over 7 minus x. And so what I'm going to do is multiply the numerator and the denominator of this by 3. Hopefully y'all thought to do this because this cleans up quite quickly and quite nicely. My numerator is going to be x minus 4. My denominator, when I distribute that 3, is 3 minus the quantity x minus 4, which ends up being x minus 4 over 7 minus x, which is exactly what I wanted. Ta-da! Okay, number D, it is known that the radius of convergence for Taylor series about f is 4, and it is the same as the radius for f prime about 4. Does the Taylor series for f prime in B converge to that at x equals 8? This is going to be a quick one also. X equals 8. So let's think about this one graphically. the center of my series is 4, and they tell you the radius is 4. Okay. They put it right on the endpoint. Okay. Radius of 4 is 8. So that is within the, okay, my initial thought process just got blown out of the water here. The answer is no, it will not converge. If x is, here's what I'm going to do. I'm going to erase that. I was trying to plot and think about my radius of convergence and where these x values are compared to my center. So I'm going to scratch that. And if x is equal to 8, if x is equal to 8, the ratio of the series for f prime is, and my ratio is x minus 4 over 3. The radius is, the radius convergence for the series f of x is 4. Uh-oh. No, it's not. It's 3. In part A, the radius about x equals 4. Oh gosh, I misread it. Okay, I'm sorry. I was thinking it was telling me that the radius was 4. So I can go back to my, it's saying the radius about x equals 4 is the same as f prime. Okay, so we already know the radius is 3. I was really confused because I was like, well, I've already done part A and the radius was 3. So the radius is actually 3. So by part A, the radius of convergence for f and f prime, because they tell you they're the same, is 3. And x equals 8 is outside that radius, outside the interval of convergence. Therefore, the series for f prime does not converge at x equals 8. The series for f prime does not converge to x minus 4 over 7 minus x if x is equal to 8. And you also could have, and I was about to do this, you also could have noted that the ratio, the ratio of the series if x equals 8 is, and my ratio up here is x minus 4 over 3. So 4 minus 4, or 8 minus 4 over 3 is 4/3, which is greater than 1, which is another reason that this would diverge. So we have a couple of different reasons that we could show that this diverges. And I believe that's it. I have finished all of the questions. My writing got really sloppy at the end there because I have a meeting with my principal in 2 minutes and I got to get down there. So if I made any mistakes, let me know, comment, thumbs up, like, subscribe, send me a check, do all the good things. And hopefully y'all did well on the AP exam this year.